the volume of a metal block changes by 0.12% when it is heated through 20 degrees Celsius. What is the coefficient of linear expansion of the metal? So, its solution is, we are given a metal block which is in the form of a cube. Now, its volume changes by 0.2%, means delta V upon V into 100 is equal to 0.12%. We can also write it as V2 minus V1 upon V1 into 100. This is a percentage change in volume. V1 is the original volume of the metal block and V2 is final volume. Now, it is heated by a temperature of 20 degrees Celsius. Theta 2 minus theta 1 is equal to 20 degree Celsius. Now, according to the law of volume expansion, V2 is equal to V1 1 plus alpha theta 2 minus theta 1. This is equal to V1 plus V1 alpha theta 2 minus theta 1. Taking V1 on the left side, V2 minus V1 is equal to V1. Here we have gamma, which is coefficient of volume expansion, gamma theta 2 minus theta 1. So, gamma is equal to V2 minus V1 upon V1 theta 2 minus theta 1. This is the coefficient of volume expansion. Now, firstly we will find gamma. We know that V2 minus V1 upon V1 into 100 is equal to 0.12. Theta 2 minus theta 1 is equal to 20 degrees Celsius. So, gamma is equal to 0.12 upon 100. We have taken this 100 on the right hand side into 1 upon 20. So, this comes out to equal to 1.12, 0.12 upon 2000, which is equal to 0.06 upon 1000. So, we can write it as 6 into 10 raised to power minus 5 per degree Celsius. This is the coefficient of volume expansion. Now, we have to find the coefficient, temperature coefficient of linear expansion, which is alpha. Now, the relation between alpha and gamma is alpha is equal to gamma by 3. So, this comes out to equal to dividing it by 3, we have 2 into 10 raised to power minus 5 per degree Celsius. So this is a answer. Now the next question. What is the rate of heat transfer through a copper rod .01 meter long and 2 into 10 raised to power minus 4 meter square in area when its one end is at 273 degrees Celsius and other end is at 373 degree Celsius. The thermal conductivity of copper is 3851 joule per meter per second per Kelvin. So we have to find its solution. Now we know that heat is transferred in metals by the conduction. We are given a rod which is made up of copper material. The length of the rod is 0.01 meter. So this is the distance between two ends. This end is at 273 and this end is heated to 373 degrees Celsius. Now the heat is transferred from the end at high temperature to the end at low temperature. So heat is flowing in this direction. The area of cross section of the wire, this rod, is equal to 2 into 10 raised to power minus 4 meter square. We know that the amount of heat transferred Q is equal to K A theta 2 minus theta 1 into T upon D. The amount of heat transfer depends upon coefficient of this thermal conductivity, area of cross section of the rod, and difference of the temperatures of both ends into time, and it is inversely proportional to distance between the two ends D. Now we have K is equal to 3851 joule per meter per second per Kelvin. Theta 2 minus theta 1 is equal to 373 minus 273, which is equal to 100 degree Celsius. Area of cross section is 2 into 10 raised to power minus 14 meter. D is equal to 0.01 meter, and the time is given as 1 second. So we have to put all these values in the equation. Q is equal to a ka theta 2 minus theta 1 T upon D. This is equal to 3851 into 2 into 10 raised to power minus 4 into 100, and the time is 1 second, upon the distance between two ends, which is 0.01. So this comes out to be equal to 7702 joules. So this is the total amount of heat transferred from N1 to N2. Now the next problem is a steam pipe at 200 degrees Celsius is covered with some material (0.05 meter thick). The outer surface is at 50 degrees Celsius. A loss of 20 kilocalorie per minute per meter of length is observed if the circumference of pipe is 0.5 meter. Find the coefficient of thermal conductivity of the material. So the solution is, in this case we are given a steam pipe which is at 200 degrees Celsius. Now it is covered with another material which is at 50 degrees Celsius. The circumference of the pipe is 0.5 meter and heat lost is lost at 20 kilocalorie per minute and per meter. Heat lost Q is equal to 20 kilocalorie, which is equal to 20 into 100 calorie, 1000 calories. The time is given as per minute, so 1 minute. This is equal to 60 seconds. Now we have to find the area of cross section of the wire. This comes out to be equal to circumference into length of the wire. the circumference is equal to 0.5 meter and the length is 1 meter. So this is equal to 0.5 meter square. Now the inner temperature is a 2200 degrees Celsius and outer is 50 degrees Celsius. So heat is transferred in this direction, the amount of heat transferred Q, and the difference of the temperatures theta 2 minus theta 1 is equal to 200 minus 50, which is 150 degree Celsius. So the amount of heat transferred Q is equal to K A theta 2 minus theta 1 into T divided by D. K comes out to equal to Q into D upon A theta 2 minus theta 1 into T. Now Q is equal to 20 into 1000 calories. D is equal to 0.05 meter. This is the wire. This is D. Area of cross section is 0.5 meter square and the difference of temperatures theta 2 minus theta 1 is 150 and time is 60 seconds. So on solving it, we have 20,000 into 0.05 divided by 0.5 into 150 into 60. 60 cancels out with 60, so this comes out 10. 110 is cancelled, so this is equal to 50 upon 15. The value is 2.2 calorie per meter per degree Celsius per second. So this is the value of coefficient of conductivity of the material. So I hope you have understood all the problems. Thanks.